This question says, suppose the galvanic cell sketched below is powered by the following reaction. We have magnesium plus iron nitrate yields magnesium nitrate plus iron in a single replacement reaction. And we have this, and we're asked to identify several parts of it, so I do want to go through that. The first thing we need to do is figure out what's being oxidized and what's being reduced. So in this case, we have magnesium going from 0 to 2 plus. So magnesium started off as 0 and it goes to 2 plus. It's lost 2 electrons, so this is oxidation. We also have iron, which is plus 2, going to iron metal, which is 0. So it gained 2 electrons, which is reduction. So if we were to write the half reactions, the oxidation half reaction is magnesium solid plus, magnesium solid yields magnesium 2 plus aqueous plus 2 electrons. And if we were to write the reduction half reaction, we would have Fe2 plus aqueous plus 2 electrons yields Fe solid. So magnesium is giving up the electrons, and iron 2 plus is gaining those 2 electrons. Well, in this case, the electrons are flowing in this direction. So if the electrons are flowing in this direction, and magnesium is the source of electrons, we define the source of electrons as the anode. So over here, we have the anode, and the anode is made out of magnesium metal. Over here, E2, we have the cathode, and the cathode is receiving those electrons, because again, the electrons are flowing in this direction in this diagram, and so it is made out of iron. The only thing left to identify is what is the solution, S1 and S2. Well, these things are in a solution of their own metal salts. So S1 is made up of Mg2 plus, and in this case, the counterion is NO3 minus. And S2 is made up of Fe2 plus, and the same counterion, NO3 minus. So this is essentially what we have going on here. The magnesium is being eaten up and forming magnesium 2 plus and releasing electrons in this direction. That magnesium 2 plus is going into this solution. On the other side, what we have is we have this iron 2 plus in solution, which is being taken out of solution to form more iron metal as the electrons come in this direction. And of course, these electrons could create a current that could do something like light a light bulb. To answer the questions below, we actually have answered all of them. We could go ahead and just figure out which one goes with which. So it says, write a balanced equation for the half reaction that appears at the cathode of this cell. Well, I didn't label it here, but the reduction is occurring at the cathode. So you kind of just have to memorize that. So the reaction that's occurring is Fe 2 plus aqueous plus 2 electrons yields Fe solid. At the anode, we have the source of electrons, or we have oxidation occurring. So we have magnesium solid yields Mg2 plus aqueous plus 2 electrons. What is the substance E1 made out of? Well, E1 is the anode, which is made out of magnesium, which is being oxidized. And E2 is the cathode, and it is made out of iron, which is forming as the electrons flow from the iron 2 plus that's in solution. What are the chemical species in solution S1? Well, we have magnesium nitrate, which is Mg2 plus aqueous, and NO3 minus aqueous, and it apparently doesn't want the state of matter here. And in S2, we have the iron 2 plus, which is gaining those electrons, and the NO3 minus in solution. And again, we don't need the state of matter. So this is essentially how a galvanic cell works.